Hello there. Now, this is the second part of our quadratic formula video. I promised I'd go through some other examples, and that's what we're going to do now. Now, if you remember, what we did is we first of all identified the A, B, and C values. So we've got A equals 1, B equals -2, just remembering that the general form, I'll go out here so we can see it all. The general form is plus bx plus c, so that -2 means that b is -2. Might leave it zoomed out so you can see the quadratic formula as well. And then we've got c is equal to 1. So straight into the formula, x is equal to -b. So we've got a -2 here, so -2 is +2, plus or minus the square root of b squared. So -2 squared minus 4 multiplied by a multiplied by c. And then I'll put the little bar over the top, all over 2a. So it's 2 multiplied by 1. Okay, do a little bit of calculations here. So it's 2 plus or minus the square root of, now -2 squared is +4, and -4 times 1 is -4, all over 2. So that's 2 plus or minus the square root of 0, all over 2. And that is equal to, well, if I'm adding or subtracting 0, I'm not really doing anything at all, am I? So I'm just left with 2 over 2, and 2 over 2 is equal to 1. And so the solution is just one solution, x equals 1. And this is one of those gotcha moments, really, where you've used a quadratic formula. Beautiful, well done. You've got the right answer even better. But in terms of the efficiency of your solution writing, have a look. Oops, actually, that was naughty. It has to be equal to 0. If it doesn't equal 0, then we can't use it. Have a look at the quadratic over here. It's x squared minus 2x plus 1. This is, in fact, a perfect square. It's x squared, 1 squared, and twice 1x in the middle. So it's actually a perfect square. So an appropriate solution would have been x squared minus 2x plus 1. Sorry about the brackets, I didn't need them, equals 0. X minus 1 all squared is equals 0 because I've recognized the perfect square. Square root both sides. X minus 1 equals 0. I don't need to write plus or minus 0 because it makes no difference. Add 1 to both sides to get x equal to 1. Okay, so that would be the smart way of doing it, really. It's the most efficient way of doing this problem. But it's nice to know that the quadratic formula does give us the right answer anyway, because otherwise the universe would explode, and that's disappointing if that happens. So mathematics is very consistent. Okay, looking at this next slide here, I've got 2 more examples, and I still haven't put them equal to 0, which is naughty of me, so I'll do that now. So we've got 2x squared minus 4x minus 3 equals 0. Let's work our way through this. A equals 2, B equals -4, C equals -3, and away we go. X equals -b, so that makes it +4, plus or minus the square root of b squared, so -4 squared, minus 4, a, c, all over 2a, 2 times 2. So having a, b, c there just reminds me of exactly what we're doing there. Let's simplify it. So we've got 4 plus or minus, and we've got -4 all squared, so that's +16. And we've got 4 times 2 is 8, 8 times 3 is 24, and negative makes it positive. So we've got root 16 plus 24, like so, all over 4, 2 times 2. And that's equal to 4 plus or minus the square root of 40 on 4. Now, what I wanted to, so that you've got 2 solutions there, 4 plus root 40 on 4 and 4 minus root 4 on 40. There's a lot of 4's happening here. I wanted to point out that sometimes it's important to split your fractions up so that you can simplify it a little bit more. I might do it over in slide 15 just so that I'm not squishing it up here. So let's go all the way down here. So we've got x equal to 4 plus root 40 all on 4, which goes to 4 on 4 plus root 40 on 4. I've split the denominator there, and 4 on 4 is 1. So I'm left with 1 plus root 40 on 4. Okay. And in a similar fashion, I will also have, so I've got x equal to that, and I've got x equal to 1 minus root 40 on 4. So that's already better because we've simplified our fractions a little bit. Now, you might be tempted to go 4 goes into 40 10 times. You can't cancel down because the root 40 is one whole thing, effectively. So there's no way we can break that up. However, Rolled gold standard says there are things we can do. I'm going to do it in the box here. So this is the root 40 going over here. And root 40 can be written as a product of a perfect square and another number. This is called rationalizing or simplifying a surd. So root 40 is in fact 4 times 10, which is the same as root 4 times root 10, and the square root of 4 is 2. So we've actually got 2 root 10 here, which means that actually x is equal to 1 plus 2 root 10 on 4, or 1 minus 2 root 10 on 4, which equals 1 plus root 10 on 2, or 1 minus root 10 on 2. If you're wondering what I did there, I simply cancelled 2 into 4, goes twice. So there you go. So that's the more rolled gold answer there, when you've noted that you can simplify the fraction-y bits. And I know fractions are a bit scary, but nevertheless, it's really worthwhile getting a handle on fraction work so you can do such things and write your answers as simply as possible. Okay, final example for this video, 2x squared minus 4x plus 6. So A equals 2, B equals -4, and C equals 6. Well, that sounds all well and good, except there's absolutely no way that that is correct. Pause the video and tell me why. If you said that the reason why it's incorrect is because I didn't put the equal 0 in, that's correct, but that's actually not what I was talking about. The point is that you should always, always, always look to see whether there are other factorization techniques you can use beforehand. And the most fundamental factorization technique is common factor. And as you can see here, I've got a 2x squared, a 4x, and a 6, which means there's a common factor. They're all even numbers. There's a common factor of 2. So x squared minus 2x plus 3 is equal to 0. The good news is, if it is an equation that's set equal to 0, then I can actually divide out this constant number, and it doesn't change it at all, because when I divide 0 by 2, I get nothing. So I've got x squared minus 2x plus 3 is equal to 0. And now I've got a equal to 1, b equal to -2, and c is equal to 3. And you can use the quadratic formula from there, and I'm not going to finish off this problem. Now, if you had used 2, -4, and 6, you would have eventually got the right answer, but by simplification. But I hope you can see that dealing with these numbers, you're going to be less prone to making calculation errors, just due to the fact you're not multiplying 6 times 4 times 4 and stuff like that, or 6 times 2 times 4 and stuff like that. So by keeping the numbers as small as possible, by using a little bit of checking first, will assist you in making sure that the number of errors you make in a problem are reduced. Okay, and on that little lecturing note, I will finish this video, and in the next video, I'm going to explain how the quadratic formula works. It's a bonus video. You do not need to watch it, but it does help cement your understanding of why the quadratic formula is what it is. Okay, I'll leave it there for this video. Thanks for listening and watching.